This is not just an airplane. This is a masterpiece of engineering.
Trucks deliver aerospace-grade aluminum, titanium, and carbon fiber materials to the aircraft factory loading area. Forklifts carefully move the heavy materials into the warehouse where they are organized for aircraft production. The tensile strength on this batch checks out.
Good, let me verify the certification.
Confirmed it matches. Large aluminum aircraft panels are submerged in chemical wash tanks to remove oil, dust, and surface contamination. Ultrasonic cleaning removes microscopic particles from titanium parts, ensuring perfectly clean surfaces for safe aircraft manufacturing. Automated laser scanners examine aircraft materials to detect surface defects, thickness variations, and structural irregularities. Engineers use ultrasonic testing equipment to identify hidden cracks or internal defects that could weaken aircraft structures. High-precision CNC machines cut aluminum blocks into exact aircraft components with extreme accuracy. Automated machines carefully place carbon fiber layers to form strong and lightweight aircraft structures. Composite aircraft parts are placed inside giant autoclaves where heat and pressure transform layered fibers into solid structures. High temperature and pressure cure the composite materials, bonding the fibers and resin into extremely strong aircraft parts. Powerful hydraulic presses form aluminum sheets into curved fuselage panels that will become the aircraft's main body. Robotic drilling systems create perfectly aligned holes for thousands of rivets used in aircraft assembly. Grinding and polishing machines smooth sharp edges and refine surfaces to achieve the exact tolerances required for aircraft parts. Epoxy resin and hardeners are measured and mixed carefully to ensure the exact chemical ratio for strong composite bonding. The carbon fibers and resin are blended thoroughly to create a uniform composite material ready for aircraft component molding. Robotic arms place each carbon fiber layer carefully into molds to build strong aircraft fuselage panels. Hydraulic presses shape composite materials under controlled pressure, ensuring exact wing and panel dimensions. Engineers verify the fiber placement and layer thickness to maintain structural integrity before curing. Composite aircraft components enter the autoclave where heat and pressure harden the layers into strong, rigid structures. Controlled temperature and pressure cure the composites, bonding fibers and resin to create durable, lightweight aircraft parts. After curing, composite panels are cooled carefully to prevent cracks and internal stress, ensuring stable and precise aircraft components. Robotic arms coat aircraft panels with primer to protect against corrosion and prepare surfaces for final painting. Polishing machines refine surfaces, ensuring aerodynamic smoothness and durability of aircraft components. Automated conveyors transport heavy aircraft components safely and precisely across the factory floor. Robotic arms handle large aircraft parts, ensuring accurate placement while reducing human labor and risk of damage. Engineers scan aircraft components with 3D lasers to verify exact dimensions and alignment. Ultrasonic inspection detects hidden cracks or flaws to ensure all parts meet strict aerospace standards. Fuselage sections are precisely joined together using robotic arms and cranes to form the main body of the aircraft. Hydraulic systems lift and attach wings, while thousands of titanium bolts secure them for structural integrity. X-ray inspection ensures internal structures of the aircraft are flawless and free from hidden defects. Each aircraft component is labeled with serial numbers and batch codes to ensure full traceability throughout its lifetime. Engine spooling up. Thrust is climbing.
Flame stable, all parameters are green.
Confirmed, holding at peak thrust. Hydraulic systems are tested under pressure to verify proper function of landing gear and control mechanisms.
Cycle time is down to 45 minutes.
Good. And the defect rate?
This steady at 0.2 accuracy and Airbus. Computer stitch robotics and strict quality control to produce safe, reliable airplanes.
Aircraft are stored in climate-controlled hangars to protect sensitive electronics and structural components before delivery. Before delivery, aircraft undergo multiple test flights to ensure all systems perform perfectly under real operational conditions.